This is a paper on the basic properties of the 6 types of triangles. Triangle geometry is a course in itself. I'm hereby only introducing the novice to the wonderful world of triangles. The basics of all the triangles will be discussed along with the minimal specifics of the individual triangles. The complexity of the 3-sided, 3-angled, 2-dimensional shape is amazing. Going 3-dimensional, we would have an overwhelming figure such as a pyramid. A triangle is a 3-sided polygon, sometimes called a trigon. Every triangle has 3 sides and 3 angles, some of which may be the same. The sides of a triangle are given special names in the case of a right triangle, with the side opposite the right angle being termed the hypotenuse, and the other 2 sides being known as the legs. All triangles are convex and bicentric. That portion of the plane enclosed by the triangle is called the triangle interior, with the remainder being the exterior. The study of triangles is sometimes known as triangle geometry and is a rich area of geometry filled with beautiful results and unexpected connections. It is common to label the vertices of a triangle in a counterclockwise order, such as you'll see in the diagram, the large A, B, C. The vertex angles are given the same symbols as the vertices themselves. The sides opposite the angles A, B, and C are labeled with a small a, B, and C, with these symbols also indicating the lengths of the sides. A triangle is said to be acute if all 3 sides of the angle are all acute. A triangle having an obtuse angle is called an obtuse triangle, and a triangle with a right angle is called right. A triangle with all sides equal is called equilateral. A triangle with 2 sides equal is called isosceles, and a triangle with all 3 sides of different lengths is called scalene. A triangle can be simultaneously right and isosceles, in which case it is known as an isosceles right triangle. An equal angular triangle is a triangle where all 3 interior angles are equal in measure. Because the interior angles of any triangle always add up to 180 degrees, each angle is always a third of that, or 60 degrees. The sides of an equal angular triangle are all the same length, congruent. And so an equiangular triangle is really the same thing as an equilateral triangle. Some of the properties of all triangles have in common are: the interior angles of a triangle always add up to 180 degrees. The exterior angles of a triangle always add up to 360 degrees. The shortest side is always opposite the smallest interior angle, and the longest side is always opposite the largest interior angle. Now let's go over a listing of some of the more popular theorems, postulates, and properties of triangles needed when working with Euclidean proofs. We'll start with, as you can see on the slide there, the first one is side-side-side congruence. If 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent, or the same. Second is side-angle-side congruence. If 2 sides and the included angle of one triangle are congruent to the corresponding parts of another triangle, the triangles are congruent. Then we have the angle-side-angle. If 2 angles and the included side of one triangle are congruent to the corresponding parts of another triangle, the triangles are congruent. Angle-angle-side. If 2 angles and the non-included side of one triangle are congruent to the corresponding parts of another triangle, the triangles are congruent. Hypotenuse-leg congruency for a right triangle. If the hypotenuse and leg of one right triangle are congruent to the corresponding parts of another right triangle, the 2 right triangles are congruent. Then we have CPCTC. Corresponding parts of congruent triangles are congruent. Angle-angle similarity. If 2 angles in one triangle are congruent to 2 angles of another triangle, the triangles are similar. Side-side-side for similarity. If the 3 sets of corresponding sides of 2 triangles are in proportion, the triangles are similar. Side-angle-side for similarity. If an angle of one triangle is congruent to the corresponding angle of another triangle, and the lengths of the sides, including these angles, are in proportion, the triangles are similar. And then we have side proportionality. If two angles are similar, the corresponding sides are in proportion. Mid-segment theorem, also called midline. The segment connecting the midpoints of two sides of a triangle is parallel to the third side and is half as long. The sum of two sides. The sum of the lengths of any two sides of a triangle must be greater than the third side. And we have the longest side. In a triangle, the longest side is across from the largest angle. In a triangle, the largest angle is across from the longest side. The altitude rule. The altitude of the hypotenuse of a right triangle is the mean proportion between the segments into which it divides the hypotenuse. And we have the leg rule. Each leg of a right triangle is the mean proportional between the hypotenuse and the projection of the leg on the hypotenuse. Now we'll touch on the triangles themselves. We'll start with the isosceles. The word isosceles is pronounced I-sos-celes, with the emphasis on the S-O-S, or sos. It is any triangle that has two sides the same length. If all three sides are the same length, it would be an equilateral triangle. Obviously, all equilateral triangles also have properties of isosceles triangle. Some of the unique properties to a isosceles triangle. The unequal side of an isosceles triangle is usually referred to as the base of the triangle. The base angles of an isosceles triangle are always equal. When the third angle is a right angle, it is called a right isosceles triangle. The altitude is a perpendicular distance from the base to the topmost vertex. Then there's some for solving an isosceles triangle. The base, leg, or altitude of an isosceles triangle can be found if you know the other two. A perpendicular bisector of the base forms an altitude of the triangle. This forms two congruent right triangles that can be solved using Pythagoras' theorem. To find the base, you have the formula 2 times the square root of L squared minus A squared, where L is the length of the leg and A is the altitude. To find the leg length given the base and the altitude, use the formula. The leg is equal to the square root of A squared plus B over 2 squared, where B is the length of the base and A is the altitude. Or you can find the altitude given the base and leg. Given the formula, the altitude is equal to the square root of L squared minus B over 2 squared. Again, where L is the length of the leg and B is the base. The interior angles. If you are given one interior angle of an isosceles triangle, you can find the other two. Remember, the two by the base are the same. An equilateral triangle is one in which all three sides are congruent, the same length. It also has the properties that all three interior angles are equal. It's really the same thing as an equiangular triangle. An equilateral triangle is simply a specific case of a regular polygon, in this case with three sides. All the facts and properties described for regular polygons apply to an equilateral triangle. Some of the properties. All three angles in an equilateral triangle are always 60 degrees each. The angles ABC, angle CAB, and angle ACB are always the same. Since the angles are the same and the internal angles of any triangle always add up to 180, that makes them 60 degrees each. The area of an equilateral triangle can be calculated in the usual way, but in this special case of an equilateral triangle is also given by the following formula. Cube root of 3 over 4 times s to the squared, where s is the length of any one side. With an equilateral triangle, the radius of the incircle is exactly half the radius of the circumcircle. Right triangles figure prominently in various branches of mathematics. For example, trigonometry concerns itself almost exclusively with the properties of right triangles. And the famous Pythagoras theorem defines the relationship between the three sides of a right triangle, a squared plus b squared equals h squared, where h is the length of the hypotenuse, a and b are the other two sides. Some of the attributes of the right triangle. The hypotenuse, the side opposite the right angle. This will always be the longest side in a right triangle. The sides, the two sides that are not the hypotenuse, they are the two sides making up the right angle itself, also called the legs. Some properties of right triangles. A right triangle can also be isosceles if the two sides that include the right angle are equal in length. A right triangle can never be equilateral, since the hypotenuse, the side opposite the right angle, is always longer than either of the other two sides. Scalene triangles are triangles where each side is a different length. They are unusual in that they are defined by what they are not. Most triangles drawn at random would be scalene. The interior angles of a scalene triangle are always all different. The converse of this is also true. If all three angles are different, then the triangle is scalene, and if all the sides are different lengths. Interior angles are all different. To see why this is so, imagine two angles are the same. The triangle would then be an isosceles triangle, which has two sides the same length. Similarly, if all three angles were the same, it would be an equilateral triangle, and all three sides would be the same length. The shortest side is opposite the smallest angle. In a scalene triangle, all sides have different lengths, and all interior angles have different measures. In such a triangle, the shortest side is always opposite the smallest angle. Obtuse. In any triangle, two of the interior angles are always acute, less than 90 degrees. So if the third angle is greater than 90 degrees, the triangle is an obtuse triangle. Acute. In any triangle, two of the interior angles are always acute, less than 90 degrees. So if the third angle is less than 90 degrees, all three angles are acute, and so the triangle is an acute triangle. In conclusion, every triangle has three sides and three angles. A side is opposite an angle or a vertex if neither of the endpoints of that side are at the vertex of the specified angle. An angle is included between two sides if the common endpoint of the sides is the vertex of the angle. Below, these concepts are pictured. Right there. There you go. It's just like we saw on the first slide. Okay? In a triangle ABC, side A is opposite angle A, side B is opposite angle B, and side C is opposite angle C. Angle A is included in sides B and C, angle B is included in sides A and C, and angle C is included in sides A and B. When triangles are classified according to their lengths of their sides, they fit into one of three categories: scalene, isosceles, or equilateral. If none of the sides of a triangle are equal, of equal length, the triangle is scalene. If two or more of the triangle sides are equal, the triangle is isosceles. If all three sides of the triangle are equal, it is equilateral. An equilateral triangle is also isosceles by definition. When triangles are classified by their angles, they fit into one of four categories. They're either acute, obtuse, right, or equilateral. If the angles of a triangle are all acute, the triangle is acute. If a triangle has one obtuse angle, remember that is one is the maximum number of obtuse angles a triangle can have, then it is an obtuse triangle. If a triangle has one right angle, it is a right triangle. And if all three angles in the triangle are congruent or equal, then it is an equilateral triangle. This concludes our topic today on triangles and their properties. Thank you. Have a great day.